Hey, how are you doing?
Good.
It's good to hear. All right. So I believe last time we did some factoring, introduced that concept.
Yeah.
Um, so are we doing more of the same today, or are we doing something else?
Let's try something else.
All right. Did you have anything in mind that you wanted help with, or is it just kind of like what comes next after factoring?
Just what comes next.
Okay. So there's more stuff to factoring that we didn't talk about. Um, so before we dive into that stuff, I just want to make sure that you want you to show me that you know how to factor. So let me grab this problem. So this is one of our quadratics. All right, let's go ahead and factor this for me, if you would.
Mm-hmm. Could you help me?
Sure. So you're on the right track. 6 and 4 was actually a pretty good guess. You're just off on the addition part. So what other numbers do you know that um, multiply to 24?
Um, I mean there's two, but that's probably not it.
So you're saying like 2 is a multiple?
Yeah, we can do the number two and then
Right.
multiply it enough.
Yeah, so it would be 2 and 12 is one of our options, but that's not going to work. Um, you did, you tried 4 and 6. That's not going to work. We have one more that's in the middle. Um, you want to take a guess at what that one is?
Would it be three?
Does it work? Yeah, see what the multiple that goes with 3 is.
Um, seven?
Not 7, because 3 times 7 is 21.
Oh,
You got to do one
eight.
more 3. Yep. Yeah. Now, does this add to 11?
Mm,
Yep.
mm,
So
yeah.
that's the idea.
Okay.
And then how do we write that in here?
It would be
Yep. Exactly. Very good. Okay. So that doesn't seem too bad. Then
yeah.
I'll.
I'm just still like I still struggle on finding
Yeah. No, that's okay. It takes
what
it takes some
multipliers in the
practice.
house.
There we go. I want to make sure you can do greatest common factoring. Okay. So you know what I mean by greatest common factoring?
Kinda.
What do you think it means?
Find the common factor, but find the greatest one.
Yeah, exactly. So go ahead and factor these two numbers: 27 times x to the 3 and 18x to the 4.
Hmm. So the x's are the common here.
Is there anything more that's common?
Um, Not that I see.
Let me. So when we're checking multiples, we basically, we want to see. So you're right. So there's commonality between x3 and x4. Um, but now we got to check if 27 and 18 have anything in common, and they will. Um, so go ahead and explore. Um, see what numbers they can be shared together. So basically, you kind of want to, if you got 27, split it up into its parts, and then whatever, you got this number times this number. Then you can do the same for 18. And then if there's any overlap, then that'll be your factor.
Hmm. 27, 9, and 3, and then 18. So the 9s are common.
Very good. Yep, so we have the x's in common and we have the 9's in common. So how would we write that factored out?
Um, with the 9 being in front, like that.
Mm-hmm. So yeah, so you're on the right track, but the greatest common factor has a different form than quadratic factoring.
Mm-hmm.
So how it looks is we only have one set of parentheses.
Mm-hmm.
So we have everything, or so we pull out everything that's shared, and we put it out in front, and then whatever is the remainder gets put in here.
Which is X.
Um, so first, what is shared between the both of them? So we got 9. What else?
I mean the other number.
What other number?
The 2 and the 3.
Nope. So this is for 27. This is for 18. Um, so 9 is already the greatest common factor. It's because like 3 and 2 don't have anything shared between them.
Mm-hmm.
But we have some x, as you had said earlier. So what's the greatest common factor of these x's?
Square. X square.
Not squared, x to the 3. And
Uh-huh.
the reason, do you see why? Because
No.
okay. So x to the 3 can be written as x times x times x, right?
Mm-hmm.
And then x to the 4, I'm going to put a plus here, it can be written as x times x times x times x. So these share 3 x's between each other. So then
Mm-hmm.
we would just write that as x to the 3 when we pull it out.
Okay.
Yeah. So how that looks is, so now we put the 9x3 on front. These are multiplied together. And then we put the remainder in. So in this term, all of our x's are gone because the x's came out here. But we're left
Mm-hmm.
with the 3. So we'll put the 3 here. And well, actually, we weren't told if these were added together or subtracted. So let's just say they were added together. So this is 27x3 plus 18x to the 4. Um, and then, so let me ask you this. What is the remainder of 18x to the 4th after we factored out 9x3?
The 2
And what else?
and the 3.
Nope. So we have this one x remaining
Oh,
as
okay.
well.
So it's 2x.
Yeah. So 3 plus 2x. And then this is our final answer.
Mm-hmm.
And how we know that we get this answer right is I'm going to get rid of these multiplication symbols because they're a little bit redundant. Okay. Yeah, so this is our final answer. And the way we know it's right is we can take the shared elements, multiply them out to both using like the distributive method, or distributive property, however you want to say. And then if whatever we get is what we started with, then we have the right answer. So let's test it. So what's 9x to the third times 3?
27.
And what else?
X3.
Yep. And then we go over plus sign. And then what about 9x3 times 2x?
18x4.
Yeah, 18x4. Yep. So that's how we check our answers. And that's all correct.
Okay.
Okay. All right, so that's a little good. So I think, yeah, we wanted to do a couple more quadratic factoring, but I don't think we'll have to spend too much time on that. Okay, so here we're going back to quadratic factoring. We'll do this problem. Okay, go ahead and give that a shot.
Mm-hmm.
Would you like a hint?
Yeah.
So the answer, or the answers rather, are always going to be multiple, or like they're going to multiply to 60.
Yeah.
So start checking those. So what numbers multiply to 60? You already found one, 6 times
I
10,
mean,
and that doesn't work.
5 times a number could get to 60.
Mm-hmm.
Same as 2, maybe 4.
Yeah, just start writing them out. See if any of them add
Ooh.
up to 17.
What about 3?
Sure. What multiplies by 3 to get to 60?
20.
20. Yep. Ooh. So these kind of add. 20 minus 3 gets us to 17. But
Mm-hmm.
unfortunately, that's not going to work because 60 isn't negative.
Yeah.
So if it was negative, that would be our answer.
Mm-hmm.
So we can cross that one off. And I'll give you one more piece of information that might help a little bit. All of these multiples can kind of be listed out in order. So you can choose, 1 times 60, um, 2 times 30, but these don't work. 3 times 20, then there's a 4, then there's a 5, then there's a 6 and a 7. So go on as so forth. So you can like check the numbers like out, in order. Or you could even like cross out some like early on if you know that they're just not going to add correctly.
Mm-hmm.
All right. So what about for 4 when we have a multiple of 4? Or what times 4 equals 60?
Um, 12? Wait, no. Uh, 15.
Yep, 15. And the easy way to figure out what this number is just to do 60 divided by that number.
Mm-hmm.
Okay. Unfortunately, that doesn't add to 17. So now let's check our 5.
12.
Okay. Now does that add to 17?
Yes.
There we go. So this is our answer. And that's how you find it. You look at the multiples of 60 and you can, go in
Mm-hmm.
order, check the 1, check the 2, check the 3, so on and so forth until you found the right number.
Mm-hmm.
All right. So 5 and 12 are our multiples. How will we write out the final form?
I feel like 12 would go here.
Hmm. Yeah, it doesn't matter the order. It
Mm-hmm.
only matters that you have the signs correct. And yeah, they'll be positive. So that's all good. Okay. Very good. Let's do one more. If you can do it like perfectly on your own, I'll be, you know, you'll be satisfied. Okay. Go give that one a shot. So before we get too far along, so you've chosen the right numbers, but the numbers will carry with them the
Oh,
sign.
yeah. Minus.
Yep,
The,
exactly. Very good. All right. And what does it look like in its final answer?
Mm, I don't think I wrote that right. Would the 1 be positive in the answer?
Yes. The one is going to be positive. Wait, hold on. Oh, whoops. Okay. I was wondering what went wrong. I'm looking at the wrong problem. Okay, sorry. So it's basically just these numbers, and then they follow their signs. So the 1 will be negative, then the 5 will be positive.
Is that
Yeah.
right?
Yep, that's correct.
Uh-huh.
Yeah. No, there was like same problem, same variables, same numbers. It's just the plus 4x was a negative, and I was looking at it and was like, what happened here? Okay. Anyways, yeah, so that all looked good, so we can move on to the next thing. So the next thing in factoring, so we've been dealing with quadratics of this form, x squared plus bx plus c, where b and c are, just numbers. The
Mhm.
next frontier is if we have a coefficient here we call a, um, and before when we've been doing this, we kind of have an a, but it's 1, so we ignore it. But when we have any number that's not 1, um, even if it's like negative, we kind of have to do a different method.
Mhm.
Um, well, so if it's -1 here, so like usually this is equal to 0. So if a is negative, you should just divide the negative out, because then it'll
Okay.
be 1 here. But so there's kind of two ways we deal with this. So the first way is through greatest common factoring. So let me give you an example of one that factors. This is a good example. There we go. Okay. So this is an example of one that we can factor by greatest common factor. So both of these terms share a 2. Do you agree?
Yes.
So then we could factor out this 2. So then it'll become n squared. What does minus 8n become?
I don't know.
So what happens when you... So we split 8 up into 2 and what number that multiplies together to get 8?
Two and 4.
Yeah. So it'll be minus 4n, because n is the last thing we have.
Mhm.
And then what happens to minus 42?
Um, we divide it into like its parts.
Yep, so it's 42 and it turns into 2 and what number? Basically, you're just dividing by 2. 42 divided by 2.
20.
21.
Mhm.
Because 2 times 20 is 40. So, but then you see, this is just what we've been working on before.
Mhm.
So we know how to solve this, so we don't need to introduce anything new. Then the answer is going to be of the form 2 n plus a number n plus another number, basically. We don't have to solve it. So this is one method. The other method, and well, this is greatest common factoring. The other method we use. Oh, hold on, let me here we go, is a problem that looks like this. And this is, to factor this, we need to use the AC method. So you'll see here that it's basically we can't break it down any further. We can't pull out a 6 or a 2 or a 3 or anything like that. It's already as like simple as we can make it.
Mm-hmm.
So how we do the AC method is, let me, I'm going to move this up a little bit so I got a little bit more room to work with. Just off to the side a little bit. So the AC method starts with multiplying A times C. So these two numbers will get multiplied together. So for this problem, that's A times C is equal to 6 times 2, because we have C and A, which is equal to 12. And then our B is 7. So it's kind of like 12 becomes our new C. So I want you to think about 12 as if it were here in the problems we've been doing earlier. So what
Mm-hmm.
numbers would we choose if we have B is 7 and C is 12?
Like what would multiply and add up to them?
Yeah, exactly.
Um, try 2 times. No, that one. 3 times 4 equals 12.
And does that work?
Uh, yeah.
Yep, it works, exactly. So this is our, so we're going to choose 3 and 4. So, but this is where the two methods are going to differ now. So instead of putting in, writing it like x plus 3, x plus 4, like this, because this is normally where we would stop in the previous problems.
Mm-hmm.
But because we have the a or the 6, it's a little different. So how it's going to look is so I'm going to write 6x squared plus 7x plus 2. We're going to split the 7x up into plus 3x plus 4x plus 2. Do you see how that works?
Yes.
Okay. Um, okay. Now we're yeah, this is fine. So now we're going to look at each of these two pairings, and we're going to do a greatest common factor of each. So what is the GCF of this one?
Um, the 2's.
Hold on, let me get rid of these boxes. So the 2's?
Mm-hmm.
What do you mean?
The x squared and then the 2.
Does 3 have 2 as a multiple?
Yeah.
So what times 2 multiplies to 3?
Oh, I thought you could just add it, but it has to multiply.
Yep, it has to multiply.
Okay.
Um, so the factor for this one is, so you're right, x is going to be one of our factors. But what number will we choose? Because there is a common number shared between 6 and 3.
The 3's.
Yep. So we pull out the 3, and then what is left over that we're going to put inside the parentheses?
The x squared and the other x.
Um, so here, actually, This might help to illustrate it better. So I'm going to split 6x squared up into 3 or 2 times 3 times x plus 3 times x. So you see that 3x is shared, and that's what we're pulling
Mhm.
out. So what's left over is what we put inside. So x and 2 are left over, but then there's nothing else left over here.
Yeah.
So what that means is we put the 2 times x here, then the addition symbol comes, and then we put a 1 here. So anytime
Okay.
like there's not a remainder, we just put in 1.
Mhm.
Okay. Does that make sense?
Somewhat. Yeah.
Okay. Let me. There we go. Okay. So this is the first part. So that's what this becomes. So now let's do it for this one.
The twos.
Mm-hmm. And is that all?
Um. That's what it looks like.
Yep. Just the twos. So what are we going to write inside?
Two.
To what?
Two. Um. Would we? Could we take the x, or are we just leaving the x there?
Um, so the x is going to be in the remainder.
Oh, okay.
Yeah. So how? So again, if we let me move this down a little bit. So if we do our, full pulling apart, we'll pull apart 2 times x plus 2. So the 2's are shared, but the 2x is left.
Mhm.
So the 2x comes down, and then, we can imagine we have a 1 here that comes down as
Yeah.
well.
Okay.
All right. So that is our final. Oops. Okay. There we go. Then this goes here. Okay. So we're almost done. We got one more step. And the last step is to recognize that these two things are shared between each other. You see
Oh
that?
yeah.
Yeah. So in the same way that we've been, factoring out numbers, we can factor out whole expressions. So basically how that looks is, these two things are shared. So we'll pull out 2x plus 1. And then we have to put in the remainders. What are the remainders here?
The three and the two.
Yep, the 3x and the 2. So then we add our parentheses. So one will be 3x plus 2, because, addition symbol comes down. And now this is our final answer. Okay. So we're going to do some more of that, but are there any questions about this process right now?
Um. Why not just do the GCF
Of what?
of the A, B, and C?
Like right at the beginning?
Yeah,
Because
because these are two different methods, right? Of
correct.
how to
Yep.
do this problem.
So this
Uh huh.
is a C method. So the difference is that this problem has a greatest common factor. This problem does not have a greatest common factor. Well, actually, it just doesn't have a factor at all.
Mhm.
So, 6 and 2 share a common factor, but 7 doesn't. And then x squared x, there aren't any x's shared between them. There aren't any numbers shared between them. So it's kind of like everything that we're used to doesn't exist anymore. So we have to use this special method.
Okay.
Okay, good question.
And what are we trying to find in the
Um,
problems?
right. So the goal is to factor, and this is the factored form. And
Mm-hmm.
so let me actually show you what's happening. Um, so let me share my screen with you. I have a graphing calculator here. This will kind of show you what's happening. So we had 6x squared plus 7x plus 2, I believe. Yep. And then we said that its factored form was 2x plus 1 times, in parentheses, 3x plus 2. Okay. So first things first. These graphs are the exact same.
Mm-hmm.
So you can see me turning it on and off. And they
Yeah.
overlap exactly. Um, what factoring this tells us, it tells us where this graph intersects at the x-axis. So it intersects at these 2 points. So you see how we have 2x plus 1 and 3x plus 2? If we set each of these individual brackets equal to 0, so if we say 2x plus 1 equals 0, we can arrange, what would this be if we solved for x? What would the number be?
2.
Does 2 times 2 plus 1 equal 0?
Yeah.
Mm-mm. 2 times 2 plus 1 is 5.
Mm-hmm.
But, so if we, it's kind of hard. I guess I can write this out kind of in steps. So we would bring over the 1. So it would be 2x equals negative 1. We would subtract 1, right?
Mm-hmm.
And then we would divide over 2. So it would be x equals negative 1 half.
Uh-huh.
You see that?
Yeah, and
So so what that tells us, we don't even have to, just from factoring it, we find that this intersects at negative 1 half.
mm-hmm.
And if we do the same thing for 3x plus 2 equals 0, so it'll be 3x equals negative 2, x equals negative 2 divided by 3. And we see that that happens at negative 2/3.
Okay.
So, so that's why we factor, and because factoring tells us where it intersects the x-axis. There we go. So that's why we do it, and um, there are plenty of reasons as to why we do this, but it'll become more clear in later math classes why finding the roots of a quadratic is so important. For now, it seems kind of
Okay.
random, but it'll be more clear later on. We kind of got to teach you it before we can, you got to learn how to use a hammer before you can start, you know, making stuff.
Yeah.
Okay. Does that answer your question?
Mm-hmm.
Okay. Then let's try. I'm gonna keep this around, so I'm gonna get a new one. Okay. So let me grab another AC method problem. All right. So this one I want you to do your best on, but feel free to ask me for help.
Mm-hmm.
And I believe you can switch between the slides as well, so you can
Yeah.
look at the previous problem if that'll help.
Yeah, I can.
Okay.
But I have a picture
Oh yeah.
on
Okay.
my other monitor.
Cool. That works as well.
Is that somewhat correct?
Yep. Now you got
Nice.
to figure out how you're going to split up negative 17 u.
Yeah.
So, what is our AC? Or what is our A and what is our C?
Our A is the 8 and
Mm-hmm.
the C is 21.
Yep, and specifically negative 21. So our AC, or 8 times C, is equal to 8 times negative 21. So what is that number?
Uh, Negative 168.
Yeah. So then that is negative 168. Um, so now we still have, what is our B?
17.
Negative 17. It'll carry the sign with it.
Mm.
All right, so now's where things get a little tricky. Because unfortunately these numbers are kind of large. Um, yeah. So next time I'll choose one with smaller numbers, but for now I'll give you one of the numbers you're gonna choose. So one of the numbers you're gonna choose is 7. So what is it? What is the other number that's gonna go with 7? That adds to negative 17 and multiplies to 168.
24.
24. Yep. So um, what sign is 24? Is it gonna be positive or negative?
Uh, it's going to be negative.
Yep. Negative 24. Okay. So then how do we write this in our equation? Mm-hmm. Um, you've got the numbers right, but remember that both of these numbers are going to have an x attached to them.
Mm-hmm.
So I'm just going to write this all the way out. 8x squared plus 7x minus 24x minus 21. Okay. All right. So what's the next thing we should do?
Take these segments
Mm-hmm.
and then find the factor or whatever.
Yep. The greatest common factor between them.
Uh-huh. So the 2's and the 20's are commons.
Um. So 2 isn't a multiple of 21 because you have to multiply 2 times 10 and a half.
Mm-hmm.
But there is something else that they share in common.
I mean, the negative signs, but I don't think that really matters.
Actually we can. So we can say that the negative signs are shared. So then we can pull out the negative out in front. So that is
Uh-huh.
one thing. So that'll be one of our shared values. I'm gonna move these over just a little bit. So one of the shared things is a negative. Um, so what numbers multiply to 21? Let's just start
Uh,
exploring the multiples of 21.
mm-hmm. 7 and 3.
Mm-hmm. Yep. So if we were like to write out all the multiples in order, we would have 1 times 21, 2 times 21 doesn't exist. Or well, 2 It does 2 times 10 and a half, but they're not whole numbers, so we ignore them for now at least. Um, yep, and then 3 is next, 3 and 7. Um, and then I think that's basically it, right?
Mm-hmm.
21 is pretty inflexible in that regard. Okay, so we have 1 and 21 and 3 and 7. So now let's do it for 24. It's very off kilter 4 I've got there, but so we have 1 and 24. What's the next multiple pair?
2 and 24.
2 and 12.
2 and 12. Okay.
Yeah. All right, then what's next?
8 or 3 and 8.
Mm-hmm. Okay. Um, is there anything else?
Um, 4 and 6.
Yep. And I think that is it. 24. I don't think that divides by 7. Nope, does not. Okay. So, um, ignoring the ones because we're not worried about ones. Do any of these share common terms?
Not that I know of. I mean, 4 and 6 is. Oh, 3 and 8.
Yeah, these share a 3.
Mm-hmm.
So basically why we did this is we were saying that all right, we see so I'm going to write this below for now. So we're saying negative 21 minus oops, negative 24. I'm not going to write the x for now. I'm just going to write this out as numbers. But we can see that, for 24 we can go, okay, this splits off into negative 3 times 8 and um, negative 21 splits off into negative 3 times 7.
Mm-hmm.
So then the 3's are shared, so we can write this as negative 3, negative 3 times 8 plus 7, basically. And if we introduce the x, all that's going to do is we put in the x at negative 24x. The x carries through, but because it's not a common factor, it gets put as a remainder. So this is going to be our factored form for this one. So we got negative 3, 8x plus 7. Any questions on that?
No.
Okay. So what about the other one?
So the commons are the x's. That's 1.
Is there any other thing else that's common?
Um, we have to expand them to see.
Sure. So how could we expand 8? I'm going to write this up here.
Whatever adds to 8. So there's 2x4. There's 1 and 8.
Mm-hmm.
2 and 4 equals to 8, but not 7.
So remember with greatest common factoring, we're just trying to see if these numbers share anything in common, if any of their
Yeah.
multiples are in common. So what does 7 split into?
I don't really know.
Yeah. So it splits into 1 times 7, and that's it.
Uh-huh.
7 is a prime number, so it doesn't have any other multiples other than 1 and 7.
Mm-hmm.
So what that means is that 8 and 7 don't share any common factors, and the x's are the only things that share anything.
Mm-hmm.
All right, so knowing that, what should we write as our factored form of that part? Mm-hmm.
And then what do we write in the parentheses?
Yep. So I'm gonna write it out. So it's gonna be 8x plus 7. And so one thing just to know is if you have 1 times something, you don't need to write the 1. You just
Mm-hmm.
have x here. So the way you know what to write in here is if you multiply this times this, it should equal this. And if you multiply this times this, it should equal this.
Okay.
Okay,
So since we didn't do anything to the 8 and the 7, we can just carry it down pretty
correct.
much.
Yep, the x, so if I were to write this all the way out here, so it'd be 8 times x plus 7 times x, and the x's are the only thing that's shared.
Mm-hmm.
Yep. Okay. So, um, yep. So this is factored like this. All right. So are we done, or do we have more to do? All
We have more.
right. So then, what's the next step?
Uh, hmm. Actually, I don't think there is more to do.
There is more to do. And the way we know we're done is when we have two parentheses like this.
Mm-hmm.
So we're almost there. Um, but if you remember in the last problem, there was one more like interesting way we could factor. We saw that these terms were shared.
Oh yeah, they're the same.
Yeah. So if we factor that out, how does that look?
Um, always write those
Yep.
and
So
take
we
away the 3 and the x.
we just straight up write this. Then we're gonna have our parentheses. And what do you say goes inside the parentheses?
Um, the 3 and the x.
Yep. So spell it out for me. How is it written? Nope. So get rid of this real quick. So the remainders of when we so these two things are shared in common, but the x and the -3 are the remainders.
Mm-hmm.
So what that means is we will put x here and then -3.
Oh, okay.
Yeah. Okay. Um. So we are almost out of time, but that was some good work we did today.
It's a lot more complicated than just normal factoring.
Yeah, yeah. No, introducing the A makes things much harder. Definitely. Yeah, so next time we'll probably continue on with this, and then we'll learn some more ways to factor. Um,
Mm-hmm.
and yeah. Okay. Do you have any other questions about like what we learned today, or just anything else in general, or
No,
okay? Cool. Then I think we're good for today.
thank you.
Yep. I'll see you next time.